Welcome back to the deep dive. Ready to explore the most fascinating 3 pounds of matter in the known universe. Today, we're cracking open a hands-on guide to brain anatomy and diving deep into the human brain. And this book is not kidding around, it goes all in, even suggests dissecting a sheep brain. We'll be sticking to the metaphorical dissection today, but still, just picturing those folds and fissures, all that intricate detail, it really highlights how much we don't know about what's going on up there. Speaking of not knowing, when we talk about the brain, where do we even begin? Every time I try to wrap my head around it, information overload.
It's true. The brain can seem like this incredibly intricate web of, well, stuff. But luckily, it's not an unsolvable puzzle. Think of it like exploring a new city. You need a good map, right? Well, in neuroanatomy, our map uses these specific directional terms. Anterior, which means front, posterior, meaning back. Dorsal for top, ventral for bottom. And then we have lateral for the sides and medial for the middle.
So if I'm picturing the brain like a compass, anterior would be north, posterior would be south. I'm getting this. I have to admit, though, those terms always sounded a little intimidating.
They can sound a bit technical. But once you have those directions down, you have the key to understanding how neuroanatomists describe any part of the brain. And believe me, it's way more fun than getting lost in the back alleys of the brain, trust me.
Right. Nobody wants to get lost in there. So we've got our map and compass. What are some of the major landmarks we're going to encounter in this brain city of ours?
Well, first off, you've got to appreciate the sheer scale of this metropolis.
Yeah.
At the broadest level, the brain has three main areas: the cerebrum, the cerebellum, and the brainstem. Think of them like the bustling downtown core, the historic district, and that essential infrastructure hub that keeps everything running.
I am intrigued. Let's start with that downtown core, the cerebrum.
So the cerebrum, this is the big cheese, the head honcho, the one calling most of the shots. It's the largest part of your brain. And it's responsible for all those things we consider part of our conscious experience: thinking, learning, memory, language. Even personality is largely housed in the cerebrum. And just like many city centers are divided by a river, the cerebrum is divided down the middle by a deep groove called the longitudinal fissure. This separates it into two halves, or hemispheres.
Wait, hold on. Is that why people say we only use 10% of our brains? Because it looks like there's a wall down the middle.
That's a myth that needs to be retired for good. While each hemisphere has its own specialties, they're in constant communication through a superhighway of nerve fibers. It's not like you've got one half just sitting there idle.
Okay, good. Because I was about to demand a refund from evolution if that was the case. But if we are maximizing our brain power, what's with all the wrinkles? It's not exactly aerodynamic.
Those wrinkles are key to our brain power. That outermost layer of the cerebrum, the cerebral cortex, that's where all the real magic happens. We call it gray matter. And those folds, the gyri or ridges, and the sulci or grooves, they're like nature's way of cramming a whole lot of surface area into a relatively small space.
So it's like our skulls are these tightly packed suitcases, and the brain has figured out how to maximize packing space for the most brain power.
Exactly. Think about crumpling up picture paper to fit it into a small jar.
Right.
You get more paper in there if it's crumpled than if it's flat, right? The gyri and sulci do the same thing. They give us maximum cortical surface area for process power. It's incredibly efficient.
Clever design. Now, I've always heard about different parts of the brain having different jobs. Is that where these lobes come in? Like, is there a creativity lobe and a doing taxes lobe?
Not quite. Though, wouldn't it be nice if we could compartmentalize like that?
Yeah.
Seriously, though, the cerebrum is divided into four main lobes, each with its own set of specialized functions.
All right, lead the way. Let's meet these lobes.
Okay, so up at the front, we have the frontal lobe, and it's always executive function season up here.
The frontal lobe, huh? So like business casual brain.
Exactly. This is your CEO brain, handling all those higher-level processes: planning, decision-making, problem-solving. It's also where your personality really shines through, shaping how you interact with the world.
So if my frontal lobe is having a bad day, that's when I make that impulsive online purchase I later regret.
It might be involved along with a few other players.
Now, moving right along the top of your head, we've got the parietal lobe. And this area is all about sensory integration. It takes in information from your senses, touch, temperature, pain, and helps you understand where your body is in space.
Okay, so the parietal lobe is why I can touch my nose with my eyes closed. Got it.
Exactly. Ever tried navigating a dark room? That's your parietal lobe hard at work.
Ah, so that's why I walk into walls when I'm half asleep. What about the other lobes? What are they up to?
Let's head to the back of the head where you'll find the occipital lobe, your visual processing center. Everything you see, from the words on a page to the colors of a sunset, gets interpreted and processed here.
Okay, so if the occipital lobe is all about processing what we see, does that mean the temporal lobe, down here by the temples, is handling sound? You got it. The temporal lobe is your auditory processing center, making sense of all those sound waves hitting your ears. But it's also deeply involved in memory and language comprehension. Remember that catchy song you couldn't get out of your head? That's your temporal lobe leaving its mark.
Hold on, so the temporal lobe is why I can remember song lyrics from years ago, but can't remember where I put my keys 5 minutes ago. Is that my temporal lobe trying to tell me something?
That's a great question, and it highlights how complex memory really is. Well, the temporal lobe plays a big role in storing long-term memories, especially those with strong emotional significance. Remembering where you put your keys involves a network of brain areas, including the hippocampus, which we'll get to later. It also involves your attention and working memory, and sometimes, let's be honest, we're just not paying attention to where we put those keys in the first place.
Okay, good point. Let's get back to exploring what other fascinating districts are waiting for us in this brain city.
Well, we've explored the bustling city center that is the cerebrum. Now, imagine we venture just a bit further back to a smaller but equally impressive district, the cerebellum.
The cerebellum. That name rings a bell. Isn't that the part that helps with balance?
You got it. The cerebellum is often called the little brain because it looks like a miniature version of the cerebrum. And while it's much smaller, don't let that fool you. It's incredibly densely packed with neurons. And it's absolutely essential for coordination, balance, and those smooth, precise movements we often take for granted.
Right. So not just walking and talking, but like
Yeah.
acing a triple axel or nailing that guitar solo. That's impressive.
Absolutely. And what's fascinating is that while we used to think of the cerebellum as primarily focused on motor control, emerging research suggests it plays a role in some cognitive functions too, like language processing and even social cognition.
Whoa, that's wild. So there's more to this little brain than meets the eye. It's like the city's hidden gem, small but mighty.
Exactly. Now, for our final stop, we're going to head down to the base of our brain city, to a region that often gets overlooked, but is absolutely critical for our survival. This is the brainstem, and it's like the city's infrastructure hub, keeping everything running smoothly behind the scenes.
Okay, so if the cerebrum is the CEO and the cerebellum is the star athlete, the brainstem is the power grid. Essential, but easy to forget about until something goes wrong.
That's a great analogy. The brainstem is responsible for all those vital functions. We don't even think about breathing, heart rate, blood pressure, sleep-wake cycles. It's also a relay center, transmitting information between the brain and the rest of the body.
So it's like the brain's own personal air traffic control, keeping those signals flowing. I'm starting to realize how much we take for granted down there.
Absolutely. And within this critical hub, we've got different departments, each with its own essential role. There's the medulla oblongata, which controls those basic life-sustaining functions, like breathing and heart rate. Above that, you've got the pons, which acts like a bridge, relaying information between the cerebrum and the cerebellum, and even playing a role in sleep and dreaming. And finally, we reach the midbrain, involved in sensory processing, movement, and even motivation.
It's amazing how much is packed into this one structure. It's like the brainstem is the ultimate multitasker, keeping everything running smoothly 24/7. I have to admit, I never really gave it much thought before, but now I'm realizing it's kind of the unsung hero of the brain.
Absolutely. It's easy to get caught up in the more glamorous functions of the brain, but without the brainstem, none of it would be possible.
So true. So we've explored the bustling city center of the cerebrum, the hidden gem of the cerebellum, and the essential infrastructure hub of the brainstem. What other wonders await us in this incredible organ? So we've explored the penthouse views of the cerebrum, toured the cerebellum's hidden gardens, even peeked into the brainstem's utility tunnels. But this is a deep dive, right? What else is down there? What are we missing?
Hold on to your hats, because we're about to do some serious brain exploration. Imagine, if you will, that we're flipping this entire brain city upside down. We're talking about the ventral view, like looking up at the city from below.
Ooh, an undercity tour. I'm in. What's down there in the brain's basement, so to speak?
Well, for one, you've got the pituitary gland, often called the master gland, because it's responsible for producing and releasing hormones that control a whole slew of bodily functions. Growth, metabolism, stress response, you name it.
Whoa, the pituitary gland. I've definitely heard of hormones, but I never really put two and two together about where they come from. Seeing it on this ventral view really shows you how interconnected everything is.
Exactly. It's like realizing the city's water supply is tucked away down here, quietly influencing everything else going on above. And speaking of connections, just behind the pituitary gland, you'll find this fascinating crossroads called the optic chiasm. Remember how each eye has an optic nerve that carries visual information to the brain?
Yeah, it's like a high-speed fiber optic cable for our eyes.
Exactly. Well, at the optic chiasm, these nerve fibers partially cross over, sending information from the right visual field to the left side of the brain and vice versa.
Wait, so that's why damage to one side of the brain can affect vision on the opposite side of the body? It's all crossed over. Mind blown.
That's right. It's called contralateral organization, and it's a key principle of how the brain is wired. It might seem counterintuitive, but it's incredibly efficient. Now let's journey from the underside up into the heart of our brain city. Imagine we're taking one of those super high-tech elevators that can move in any direction. Up, down, even sideways.
Okay, I'm picturing something out of a sci-fi movie. Where are we headed?
Picture this, we slice into the brain like it's a perfectly baked cake. Looking at these cross-sections, these brain slices, reveals a whole new layer of intricate detail.
Ooh, cake layers. Now you're speaking my language. What kind of structures are we going to find nestled in these layers?
Well, first off, remember those ventricles we mentioned earlier? In these slices, we can actually see those fluid-filled cavities that help cushion and nourish the brain. They're crucial for the flow of cerebrospinal fluid, or CSF, which is like the brain's very own life support system.
CSF, so it's not just empty space in there. There's actual fluid circulating throughout the brain.
Precisely. CSF is constantly flowing through the ventricles, removing waste products, delivering nutrients, kind of like the city's sanitation and supply chain, all rolled into one. And as we go deeper into these layers, we discover this massive structure called the corpus callosum, a thick band of nerve fibers that acts like a bridge between the two hemispheres. It's how the left and right sides of your brain communicate and work together.
So it's like the corpus callosum is the brain's superhighway, ensuring smooth communication between those two bustling hemispheres. No wonder it's so prominent in these slices. What else is hiding in plain sight in these layers?
We also get a glimpse of the basal ganglia. They're involved in a whole range of functions, from movement control to motivation, even reward and pleasure. Think about that feeling of satisfaction when you achieve a goal. Your basal ganglia are likely involved in that little dopamine rush.
Okay, that's way cooler than I ever imagined. And it reminds me, earlier we were talking about how I can remember song lyrics, but not where I put my keys. Is there a specific part of the brain that's responsible for forming and retrieving memories?
You're reading my mind. Tucked away deep inside the temporal lobe, we find the hippocampus. It's this small, seahorse-shaped structure that plays a critical role in forming new memories, especially those related to facts and events. Think of it like the brain's librarian, carefully cataloging your experiences for future retrieval.
Ah, so if the hippocampus is the librarian, maybe my where did I put my keys memories are just getting lost in the stacks.
Perhaps. It's important to remember that memory is a complex process that involves many brain regions working together. But the hippocampus is definitely a key player, and damage to this area can have a profound impact on the ability to form new memories.
It really puts things in perspective, doesn't it? I mean, we started with basic directions, explored lobes, dove into these hidden structures, and we've only just scratched the surface of how this incredible organ works.
It's true. And the most amazing thing is that our brains are constantly changing, adapting, and rewiring themselves based on our experiences. Every conversation, every new skill you learn, every memory you make, it's physically changing the structure of your brain.
That's both terrifying and kind of awe-inspiring at the same time. It's like this whole deep dive has been an exercise in realizing just how much we don't know about the very thing that lets us know anything at all.
It's a journey of endless discovery, and I have a feeling this is just the beginning of your own exploration of this amazing universe inside your head.
I have a feeling you're right. Huge thank you to our expert for illuminating this fascinating landscape. And to our listeners, thank you for joining us on this incredible deep dive into the anatomy of the human brain. We've only just scratched the surface, but hopefully you've walked away with a newfound appreciation for this intricate, complex, and utterly amazing organ that is your brain. Until next time, keep those synapses firing, and remember, there's always more to discover.
Words that flow like rivers do. Learn a language, join the crew. Every lesson something new. Lengua Viva here for you.
Grammar rules and vocab tight. Practice every day and night. Conversations feeling right. Change your world with words so bright.
Lengua Viva, take a chance.